Welcome to the video for C2.3.4 where we're going to look at nanoparticles. So our learning objectives for today, you need to be able to recall the relative size of nanoparticles, describe and explain the properties of nanoparticles, and then relate the properties of nanoparticles to both the uses and the possible risks. So new keywords for today. So a nanoparticle is a particle between 1 nanometer and 100 nanometers across. And they contain just a few hundred atoms because of their size. So a nanoparticulate is the aggregate name, so the group name for something that's composed of nanoparticles. So here's the typical exam question that you might meet. So the size of a nanoparticle is similar to the size of a molecule. Which of these best describes the size of a nanoparticle? So pause the video and based on what we said on the previous slide, try and answer this question. Okay, so hopefully you've chosen option B, because on the previous slide we said it was between 1 and 100 nanometers. So this is too small and these two are too big. So here's another slightly more complicated nanoparticle exam question. So scientists compare the size of nanoparticles to the size of other small objects. Look at the table. So it gives us a diameter in nanometers, and it says the diameter of a DNA strand is 2.5 nanometers. Explain why DNA is a nanoparticle but a water molecule is not. So we need to come back to this definition of the nanoparticle is between 1 and 100 nanometers. So it's asking us to explain why that is. So 2.5 is between 1 and 100 nanometers, so that is a nanoparticle. The water molecule is 0.27, so it's too small. It's outside this range of 1 to 100 nanometers, so it's not a nanoparticle. So that's the first bit. And then it's asking us to calculate how many zinc oxide nanoparticles would fit across a human hair. So a human hair is 100,000 nanometers, and a zinc oxide nanoparticle is 32. So the zinc oxide particle is 32 nanometers, and a human hair is 100,000. So to calculate how many of them are going to fit, I'm just going to divide the 100,000 by 32, and that will tell me how many particles will fit across a human hair. So if you stick that into your calculator, you will get 3,100. And it tells you to give it to 3 significant figures. So it needs to be 3100. I think in your calculator it comes out as 3125. So if you've done that, that would be 1 mark, because you've not done it to 2 significant figures. Right, so nanotechnology is talking about our use of nanoparticles. So nanoparticles, because they're very, very small, they've got a high surface area to volume ratio. So as you'll see when we get to rates of reactions in year 11, the size of a particle means, so it has an effect on the rate of reaction. So if you have a very high surface area, you're going to have a higher rate of reaction. So nanoparticles can react very, very quickly. So if we've got 2 representations there. So we've got this diagram here with so that's one big block that's going to have a low surface area to volume ratio, and then the one where if you split that same volume into 4, you have a higher surface area to volume ratio. And because nanoparticles are very, very small, they've got a very large surface area to volume ratio compared to normal particles, and that's useful for substances such as catalysts. So a catalyst, we haven't met this term yet, but so catalysts are substances that increase the rate of reaction, but they're not used up themselves. And we'll see that more in Unit C5. So if you've got nanoparticles, make very good catalysts because you've got a very high surface area. It will massively increase the rate of reaction more than if you had larger particles. So just a quick idea of where the name come from. comes from. So nano means dwarf in Greek, and it's a prefix used in maths to mean 10 to the minus 9 meters. So here's another exam question. So it's given us a cube-shaped nanoparticle with size of length 50 nanometers, and it wants us to calculate the surface area to volume ratio. And it gives us the equation here. So the ratio is the surface area divided by the volume. So the surface area, so each of these sides is 50 nanometers. So the area of one side of these cubes is going to be 50 squared. And each cube has got 6 sides. So my area is going to be 50 squared times by 6. And then my volume, so the volume of a cube is going to be 50 to the power of 3, because it's 50 cubed. So the ratio is the surface area divided by the volume. So the surface area is going to be my 50 squared times by 6 over the volume, which is 50 cubed. And if we stick that into our calculator, we will get 15,000 divided by 125,000, which gives us 0.12. So what do we use nanoparticles for? So we can use them for paints, we can use them for cosmetics, so makeups, we can use them for medicines, we can use them for catalysts, we can potentially use them for safe self-cleaning ovens. So there's many advantages to nanoparticles. They can be used in sun creams, which kind of comes under the cosmetics, I guess, although it's a useful cosmetic. But when we're using nanoparticles, we need to be aware of their potential risks. So because they're really, really small, that has benefits, which is why we can use them as catalyst example. But it also has risks. Because they're really, really small, they're small enough to be absorbed through the skin. So they can absorb through our skin and enter our bloodstream, and they can cause problems inside our body. They can also be breathed in, and whether they're absorbed or breathed in, they can pass through to our cells and they can cause problems in our cells. Because they're really small, they might take a long time to break down in the environment, and they can also have toxic substances stick to them. And if they have toxic substances that stick to them and then they get absorbed into our body, then that's going to cause massive problems. So again, here's another exam question. So a new sun cream has been developed using zinc oxide nanoparticles. The small particles provide better protection from the sun and they don't leave white marks on the skin. Explain one possible risk of using nanoparticles in a sun cream. So pause the video and have a go at this exam question. Okay, so what they're looking for in the mark scheme here is the idea that we could breathe it in, we could absorb it through our skin, we could absorb it into the bloodstream, or that it could take a long time to break down in the environment. Okay, so 2 more exam questions here, so pause the video and have a go at these. Okay, so it wants us to describe a property that makes them useful as catalysts, and then it wants us to do a calculation around the size of nanoparticles. So the large surface, so for why it's useful as a catalyst, it wants this idea of a large surface area to volume ratio. If you've just put large surface area, then you only get one market. It needs to be the idea that's a large surface area to volume. So we need this idea that it's a ratio of the surface area to volume. So for this calculation here, it tells us that one titanium oxide nanoparticle has a mass of 5 times 10 to the minus 3. It tells us the total mass is there, so our number of particles is going to be the total mass over the mass of one particle, which is going to be our 80 divided by 5 times 10 to the minus 3. And they're both in milligrams, so we don't need to worry about that. And when you do that, it comes out as 16,000 particles. Okay, so which statement about particulate materials is not correct? So pause the video and just record your answers A, B, C, or D. Okay, so hopefully we've correctly identified A. So nanoparticles can't be smaller than atoms because they contain more than one atom. So the only thing smaller than an atom are the subatomic particles. We can use nanoparticles as catalysts. They do have an extremely large surface area to volume ratio, and there are possible risks which are difficult to predict. Right, there's a really good video here that's worth having a watch at. If you don't want to have to type in that YouTube address, if you go to the PDF file version of this PowerPoint, you can click on the link there. Right, so the last thing you need to do is just use one of these three to summarise what you've learned in today's lesson. Okay, thank you for listening. See you next time.